All right, we're live. Here we go. This is section 1.4. The title of it is Solving Linear Systems. You've done this before in Algebra 1, but I bet you haven't done it with 3 equations and 3 unknowns, and that's where we're going to spend most of our time. So I'm going to remind you, and it better be a dredge up from your memories on how to do a 2x2 system. Then I will spend most of my time on a 3x3. So, actually, no, that's not the case. I will show you one. A 2x2, so that you can remember how to do it. If you'll turn back a page, on page 29, that's where I'm actually at. I want to show you how to solve 2 different systems of 2 equations, just to remind you the method that you used before. So on page 29, exploration 2, part A, like I'm showing you there, we got 2x plus y equals 5, x minus y equals 1. I can't even remember long enough to write it down. 2x plus y equals 5, x minus y equals 1. Do you remember seeing stuff like this, where they're presented to you 2 at a time, and you have to solve the system? I'm going to show you 2 ways to solve this system, and then I'm going to do one more, and then we're going to move on to the 3x3s. Okay? So in this particular case, I happen to notice that this one has a coefficient of 1 in front of it. So does this. Even this has a coefficient of -1. If any of these 4 things on this side where the variables are have a coefficient of 1, then substitution is a pretty good choice. This is what I mean. Since this has a coefficient of 1 right here, I'm going to rewrite this as y equals -2x plus 5. You should recognize that that's a legal thing to do. Do you? You can scoot that 2x over and call it a negative on the other side, right? Then this is the substitution. Then you take what y is equal to, this guy right here, and you replace this y right there in the other equation. That's the substitution. And so now we're going to rewrite this equation right here. I know there's arrows going everywhere. But hopefully if you see the video, you'll understand what's going on. And so I have x minus, not y, but what y is equal to up here, which is -2x plus 5 equals 1. Now I have an equation that has only x's in it. And you have the skills at this point to solve it. So the first thing I'm going to do is distribute that negative. I'm going to do 2 moves. The next one, I'm going to combine these, which would be 3x, and at the same time kick this 5 over and add it. And divide. Did you catch that? Then there's another substitution. Once you figure out what x is, you got to take that value of x and come back up here, plug it in to find out what y is. So that would be y equals -2 times 2 plus 5. That's -4 plus 5 is 1. And so we say that these 2 cross at the point 2, 1. This line, which is, it is a line, it's a standard form, you're not used to it very much, but if you graphed this line and you graphed this line, they would cross each other at 2, 1. Okay? Now I'll show you another method for solving. In order to get 2 birds killed with 1 stone here, I'm going to go to exploration 1, part B. And I have to keep erasing because I have to stay where this thing can see it. So sorry about that. So part B on that one says 2x minus 3y equals 3, and x plus 2y equals 5. Now notice that over here, this has a coefficient of 1. So I could use substitution, but I want to demonstrate something else for you, so I'm not. I'm going to choose something else. What I'm going to do now is what is a process that your textbooks have called elimination. I don't like that name, but we're going to use it. What we're going to try to do is we're going to try to doctor these up, one or both of these, so that I can rewrite equivalent equations, but have one of the variables add out. So what I'm going to do is I'm going to multiply this equation here through by -2, so that I'll have a 2x here and a -2x here. And if I multiply every term in this, in other words, both sides of this by -2, I haven't really changed this line. I've just changed the way it looks. It's the same line. So if I distribute that -2 through there, I'm going to write the result right below it. It's going to be -2x minus 4y equals -10. This thing right here, this line, is exactly the same as this line. Because I multiplied both sides by the same thing. I've not changed it at all. I just changed the way it looks. So I'm going to cross this version of it out, and I'm going to add this one to this one like that. The x's are lined up, the y's are lined up, the equal signs are lined up, the constants are lined up. If that's the case, we can add it like an addition problem. 2x and negative 2x is 0. That's why I did it. Now, negative 3y and negative 4y is negative 7y. 3 and negative 10 is negative 7. Oh, that's a happy thing. That's a real easy division. But by doing this elimination method, by eliminating the x's, I have created an equation with only one variable. It happens to be y this time. There's only one variable. And if there's only one variable in an equation, you should have the skills to solve. When you find out what the variable is that you have left after you eliminated the other one, whatever you find out that is, you've got to come back in either this equation here, or this one, something above the line, and plug in this value for y to figure out what x is. I choose this right there. So it's going to be 3x. I'm asking you to do the arithmetic in your head. It's not that hard. Negative 3 times negative 1. Oh, sorry. Negative 3 times 1, which is what I got for y, is negative 3. Equals 3. And again, I have an equation with only one variable, and this time it's x. So I'm going to have 3x equals 3 plus 3 is 6. X is 2. So I get the point 2, 1 again. Did I make a mistake? I know I did. I
was just wondering, I don't know, maybe this is a mistake, but how did 2x go to 3x?
Oh, I don't know. That's the mistake. Because this should not have worked out. The whole thing should have come out to be bad. So, and did I make a mistake here?
No, it's 2x minus 3 instead of 3x.
Right. But this over here is 2x. I realize that error. But did I make a mistake here?
I didn't see one.
There should have been. The reason why there should have been is because I'm doing the system, which is b part 2x minus 3y equals 3. X plus 2y equals 5. Because they're parallel lines. That's the reason why there should have been a problem. There should have been no solution. These guys never crossed. So I'm trying to figure out what error I made. Negative 2, that would be negative 4. Negative 2. That was a positive 2y, right? Yeah. And that's negative 10. Close that out. That is negative 4. That's negative 7. It's negative 7. Hang on a minute. Oh, wait. Did I make a mistake? Oh. My fault entirely. In exploration 1, you were supposed to match the system with the equation. This matches, the B one that I just solved matches the C equation. That's what's going on. Crosses at 3, 1. That was my error. Okay? So this one does actually work out, and the point where they cross is the point 3, 1. And because of that, the second set of equations in exploration 1 goes with the C graph because they cross at 3, 1. Do you understand?
Yeah.
So I'm saying? Okay. Just notice this because as we do the 3 by 3s, we're going to come across this. Notice the A graph in exploration 1 appears to be just one line. And yet we're supposed to match a system. Here's what happened. One of those two systems, not the B one, because we already figured out what A goes with, but one of the other ones, A or C, have a system of equations presented to you such that they are exactly the same line. If that's the case, then one graph's right on top of the other. It looks like there's just a single line. And I think A goes with A. No, A goes with B. C goes with A.
Bless you.
Okay, so sometimes you will get no solution because you'll end up with, things will add out entirely and you'll end up with something like 3 equals 0, which can never happen, which means there's no solution. Sometimes you'll end up with something that's always true, like 3 equals 3, which is always true, which means those lines are always the same. So sometimes you can get infinite solutions, sometimes you can get no solution. Most of the time you get one solution because they cross. We'll talk about that more as we run into that situation with the 3 by 3s. So turn a page. We're going to jump right to example 1, and I'm going to show you the details of how to solve a system that has an x and a y and a z. It's like three-dimensional things. It's like saying x and y and z. It's called free space. Okay, this is two space. This has got a horizontal and a vertical, and we also have another axis called the z-axis, and it provides depth, provides the third dimension. You don't need to understand the graphing part of it. You just need to understand that we've got three variables and three equations, and we got to try to figure out what x value and what y value and what z value make them all true at the same time. That's our goal. That's what we did here. What x value and what y value make both of these things true at the same time? And the answer is the one place they cross. That's the one point they share that makes them both true at the same time. Now we're looking for 3. Process is very similar, but much, much more involved. So, jump to example 1. I'll show you the details. And then, I will show you a way to do it on your calculator. It'll be fun. But we're going to learn how to do it algebraically because a couple of points on the test, a couple of things on the test problems that you have, you're going to have to show your work to get full credit. So you're going to have to know how to do this by hand as well. Sorry. So, first system to solve. 4x plus 2y plus 3z equals 12. X plus 2y plus 3z. The reason why I always cross my z's is because my z's look like 2's. You may want to adopt the habit as well. If that's a variable, you can't tell your z's from your 2's, you better make a distinction. 2x minus 3y plus 5z equals -7. And 6x minus y plus 4z equals -3. Howdy.
I'm interrupting.
Oh, sorry.
Can you come visit me on your prep?
Sure.
You have time today?
Sure.
Okay.
You gonna be in your office? Okay.
See you then.
I'll be there. Terrible when the superintendent wants to see us, like get sent to the principal's office. Okay. Alrighty. So to solve this system, you got to take a minute and look at it, and especially on this left side where the variables are, you got to start looking at the actual numbers here and ask yourself, how could I easily, the most easy way that I could, how could I get one of the variables to add out, either x, y, or z, and it doesn't matter. Add out like the thing I just showed you. So, for example, I could get, and by the way, you only consider 2 equations at a time. Just 2 at a time. So if I consider these 2, I could get the x's to add out if I multiplied this by -2. Do you agree? I could get the y's to add out if I multiplied this one by 3 and this equation here by 2, because that would give me a 6 and a -6. I could get these to add out if I multiplied this one by -5 and this one by +3, because that would give me a -15 and a +15. That seems to be the worst possible case scenario, because I got to multiply them both by something. I got to multiply one by a positive and one by a negative, and these are the biggest possible numbers. These are all small over here. The easiest thing, it appears to me, to be able to do is to multiply just this one by -2. Do you agree? Now, that's the easiest thing if I'm considering these 2. Now you've got to also say, if I was to consider either this one or this one, or this one and this one, it doesn't matter, either these 2 or these 2 next, could I get that same variable to add out fairly easily? The answer is yes. You could multiply this one by -3 to get it to add to this one. So x, if you study it for a minute, x looks like the best one to try to get to add out with the least amount of effort. And it has to happen. You have to get the x's to add out, or the y's or the z's. You have to get them to add out in this combination and some other possible combination. So I'm going to work on these 2 first. This is my choice. And I'm going to write 4x. I'm not going to change the top one. It doesn't need changing. So I'm going to write this down. You got to write it all down, I'm afraid. And this one I'm going to multiply through by -2. And I'm only putting that there to remind me that's what I'm doing. It goes through all of these. I'm multiplying both sides by -2. So I get -4x, +6y, negative 10z, and positive 14. Now we'll come back to these two in just a minute. I want to work on this. So what I get is these add out. That's how I designed it. That adds up to 8. This adds up to negative 7. This adds up to 26. Are you following me? Now I'm going to leave that hanging there. Now I'm going to use these two, and I'm going to erase this so that I can remember that I'm working on these two. Now I'm going to make these two get the x's to add out. It has to be the same variable that you lose in the first two moves. So in this case, it's x. So I'm going to multiply this through by negative 3 and write it down. That'll be negative 6x, positive 9y, negative 15z, and 21. That's the most common error, is that people forget to also multiply this by this last one too. You have to multiply both sides by it. And then I'm just going to write this one underneath it because it's going to remain the same. People say, I don't want to write that much. Too bad. If you don't write this all down, you're going to make mistakes. You might make them anyway. The x's add out again, which is how we designed it. I get 8y. I get negative 11z. And 21 minus 3 is 18. Do y'all agree? Now I use these two and treat it like a system of two equations, because these are both written with a y and a z in it. So now I treat it like you learned in Algebra 1. Take these two and treat it as a system. So I'm going to have this. I'm going to write them together so I can see them clearly. 8y minus 7z equals 26, and 8y minus 11z equals 18. I hope now that you see these sitting together, it's very clear that all I want to do is run a negative through one of them, so I get a negative 8y and a positive 8y. So they add out. You with me? So I'm going to multiply this one through by a negative, and I'm going to write the result of that right under here and then forget that one. It's going to be negative 8y plus 7z equals negative 26. Y'all clear what I did there? I don't need this one anymore, so I'm just going to draw a line through it. When I add these, the y's add out, and the z's add up to negative 4, and the numbers add up to negative 8. You with me? Now I finally have an equation with only one variable in it, and it's z. So if I divide, I get that z equals 2. Now I got to backtrack to the beginning to find the others.
Yay!
Yeah, more substitution. So choose one, just like it was just a regular 2x2 that I demonstrated for you. Decide whether you're going to plug it into this one, or this one, or this one that you crossed out. I'm going to use this one. So just to remind you how that goes, I'm going to plug it in right there, and that's going to be 8y minus 22. You understand what I'm doing? Negative 11 times what I got for z is negative 22. I'm plugging it in and doing the arithmetic. You with me? Equals 18. Now I've got to solve this. What's 18 plus 22? Come on, people. Get with me here.
5.
Well, yeah, the division, but could you add 18 to 22, okay? Can you do that quickly in your head?
40.
Well,
30. No.
30. Here's how I do it. Here's how I do it. If I took the 2 on the end of this and added it to this, it would be 20 plus 20.
Yeah.
Right? Yeah, okay. So y equals 5. I now know that z equals 2 and y equals 5. What I don't know is what x is. So now I got to come clear back over here. Either here, one of these, or one of these, or one of these, any of these over here on this. I like these over here, they're cleaner. I'm going to plug those two values, 2 and 5, into this equation right here. And that would give me 4x. Y was 2, so it'll be plus 4. Do you see what I'm doing? I'm doing 2 times 2 is, oh, that was z. Sorry. It's not 4. It's 10. Sorry. Wrong plug-in. Do y'all see it? 3 times 2 is 6. And now I've got 12 minus 16. Do you see that? We're going to write the answer as a point. It's just going to be an x, y, z point. So the answer is negative 1. It goes in the first spot. Y goes in the next spot. and z value goes in the next spot. This three-dimensional point is a place where all three of these three-dimensional lines cross each other. Actually, they're planes. They all cross in one point, and this is it. You'd have to go left one on the x, up two on the y, and out five on the z, and that would be the point where they would cross. Sorry, back one on the x, up five on the y, and forward two on the z. And that point that's out there in space would be the place where these three planes cross each other.
So on the z-axis, when it's closer to you, that's when it's positive? When
Yes.
it's on the other
Yes,
side?
yes, it goes into the board, that's the negative. Yep. Okay, so let me review real quick now that it's all up here on the board. Here's the system. Shh. We studied these 9 numbers over here until we found some things that look nice for getting one of them to add out. It's not always x, but it was in this case. Because these were all multiples of 2, it was a lot easier to get those to add out. So once we make that choice, we take 2 of them. Doesn't matter which 2, I just chose the top 2. Multiply through by something appropriate so that the x's will add out, leaving me with an equation in y and z. I do it to the other 2. I could have done it to this one and this one, but then I would have to multiply this one through by 3 and this one by 2. To get a 12, I don't want to do that. I don't want to require a multiplication here to get this to be a negative 6. So I doctored one of those up, wrote it down here, added those x's out, so I had an equation written in y and z. Then I took those 2 results, y and z, and made a system out of them and caused one of their variables to add out, in this case y, leaving me with an equation written in only one variable. Solved it, then I started backtracking. I found this y value, and now I have a y and a z, and I backtracked clear over to here and wrote an equation that had only x in it by making those substitutions. Write the thing down as a point. Wasn't that fun?
Oh, so fun.
It was fun.
Oh boy, that's one problem.
One problem. I don't have 50 of them for you to do. I have 2 or 3 like this.
Okay.
Enough to get you enough practice, but not to just make busy work for you, hopefully. Okay, now let's look at example 2, because something weird is going to happen with example 2 that didn't happen here. So we're going to use the very same process. We're going to approach it the same way. We're not going to try to anticipate that there's a problem. We're going to deal with it when it shows up. So, and it is going to have a problem. This equation, just so you know, and get yourself set up, this one has no solution. They don't, all 3 planes that we're going to be dealing with do not meet in a single point. And as we go through the algebraic process of trying to get them to meet in a single point, we will discover it and how to interpret it. So I have x plus y plus z, that's nice, easy. Whenever there's ones, it's a lot easier to deal with. 5x plus 5y minus, no plus, 5z. Right there, you can tell there's going to be no solution. Or at least that there's going to be a problem. Because because this equation on the left side is 5 times this one, but this is not 5 times this. This should be 10 if they were going to be exactly the same one, but it's not, so there's no solution. But anyway, you can sometimes recognize it as you're writing it down. Sometimes you can't. Sometimes they're just too weird and different. But anyway, let's pretend we didn't recognize that one was a multiple of the other, and we just start trying to solve. Note that this is a 1, a 5, and a 4, and they are not multiples of each other. This 5 and 4 is particularly going to be difficult to deal with. We could do the 5 and the 1 and the 4 and the 1 if you want. We could also, these are all 1s here, we could just multiply this by negative 5 and use it on this one, and this by negative 5 and use it on this one to get it to add out. 5 and 3 are not multiples of each other, but I could, there's a lot of things we could apply here. Do you want to get the x's or the y's to add out? Want to do the x's?
Yeah.
Okay, then I'm going to need to multiply, if I'm working with these 2 first, I'm going to need to multiply this one by negative 5 to get it to add out with the x's. So I'm going to have negative 5x minus 5y minus 5z equals negative 10. Here's what I did, in case you were wondering what the heck I'm doing. I ran a negative 5 through there so that I would have a negative 5x and a positive 5x. So now I'm going to just write this one down underneath it. Okay, and then, because we designed it so the x's would out, we draw a line here, those add out, that's 0, oh crap, that's 0, 2. Oh no, that's 0, 2, and I end up with 0, no variables at all the variables added out, 0 equals -7. And 0 does not equal -7 ever,
So.
ever.
So right there, you just say.
Yeah, you stop right here, there's nothing more to do. When you get what we call a paradox, or something that cannot possibly be true, you write no solution and move on.
I like those.
Yeah, those are nice. Those are nice.
Whenever I get those, I'm like,
You all set? You ready to go on to the next one?
Oh, yeah.
You see how we arrived at that? Anytime. And by the way, this one might have worked out to solve for, gotten a system written in Y and Z or X and Z or something like that. And then you try the next one. If that happens on the next one, that tells you you're done. If you get these and this one to give you an equation written in Y and Z, and when you go to work on the Y and Z's they add out, that's an indicator there's no solution. So it could happen anywhere along the process. Happened first here for us. That was nice. Actually, if you're thinking about it when you write it down, you could have told that it wasn't going to work out. Because while I multiply every one of these by 5 to get this, I would have to multiply this by 5, and that is not. That should have been a 10 to make these exactly the same. So since it wasn't, those two planes are parallel to each other. They never hit. Okay, so let's go on to the next one. Notice what the example 3 says. It says solving a 3-variable system with many solutions. Many meaning infinite. It's a minimal word for infinite. Okay, so we'll go after this one just like we did the others. X minus y. X minus y plus z equals -3. X minus y minus z equals -3 again. And, oh, yeah, that was right. X minus minus, yeah. Okay. And then 5x minus 5y plus z equals -15. Okay. These coefficients, the numbers on front of the variables, these coefficients here are pretty easy to use. I could get the z's to add out right here. Just the z's, without doing anything to either one of them. Because I got a positive z and a negative z. Do you see it? The question is, could I get the z's to add out with another pair of equations? Absolutely, right there. That's what I choose. The z's have nice things. They have opposite signs and equal numbers in front of them. That makes it nice. It adds right out. So I'm going to take the first two. So this is the process we always begin with, even if we see what's going to happen as we go along here. And I draw a line because the z's are ready to add out right now. X plus x is 2x. Negative y and negative y is -2y. But z and negative z is 0. And -3 and -3 is -6. So far, so good. You following? So I'm going to take the bottom two now because their z's are going to add out too. I could use the first and the third, but I'd have to run a negative through one of them to get the z's to add out. But these two have it ready to go right now. So I'm going to use those two. X minus y minus z equals -3. 5x minus 5y plus z equals -15. I'm going to add those together. I'm going to get 6x, -6y, z's add out, that's how we designed it, equals -18. So far, so good. We got an equation, two equations written in x and y, so we're going to stack those together. 2x minus 2y equals -6, and 6x minus 6y equals -18. So now we have to ask, what do we want to do to this equation to get either the x's or the y's to add out? Do you want the x's to add out or the y's? Can you tell which choice you want to make?
Yeah,
Same effort either way, right? So what do you want to drop out? The x's? Okay, so multiply this one by -3, so this will turn into a -6. And I get -6x plus 6y equals 18. I don't need this one anymore, and I add those together, and the x's add out like we designed, but so do the y's. And so do the constants.
So it's infinite.
So the question, yeah, it's infinite, because 0 always equals 0. Before we had 0 never equals -7. So if the answer is never, this never happens, no solution. This always happens. 0 is always equal to 0, no matter what. So we say that there are infinite solutions. How we doing? You okay? You see how to make the decision whether it's no solution or infinite or possibly one. We did one with one, and we got a point out of it. You following me?
Pretty solid.
Okay? Last thing, although I'm going to show you how to do this on your calculator so you can check your work. You are going to have to show your work, but at least you can check it and see if you got it right. The last thing I need to show you is a real life problem here on what gives us a system of three equations to be solved. So I'm going to erase this for now, and we're going to talk about seating at a concert where you pay a different price for seats depending on how far back from the stage you are. You're all familiar with that, right? If you're going to be up front where you blow your ears out, it costs you more, which is dumb. Okay, please look at the diagram with example 4 on page 33. Page 33, top of the page, that diagram there is showing you a bird's eye view of this stadium seating. Notice where the stage is. Here's what it says. An outdoor amphitheater, that's not what it says, but that's what it means. An amphitheater charges $75 for each seat in section A. Right up there where you blow your ears out. $55 for every seat in section B. It's a bigger section, but it's farther back. It's $55 a seat. And $30 just to come sit on the lawn, bring your own chair. For $30 to be there and listen to this band, whoever they are. Okay? So we've got $75, $55, and $30 for each seat in each of those sections. Now comes the part that people always have the most trouble with. There are 3 times as many seats in B as in A. The revenue, remember what revenue is? Total take for the sales?
Yep.
The revenue for selling all 23,000 seats is $870,000. Question is, how many seats are in each section? Well, we got to put this thing together. How many seats are there?
800 something.
No, how many seats are there?
23,000.
23,000.
That's the first thing you should ask yourself is it's called a number equation. It has to do with how many there are. It has nothing to do with their value. We're not talking dollars here. Total seats. So if A, this is kind of stupid to write down in some cases, but I'm going to write it anyway. If A equals the number of seats, the total number of seats in section A, that might be something like, I don't know, 150 seats maybe, something like that. But it's just a number. It's the number that's in A. So B, of course, is the number in section B. And C, we're going to let that be the number of seats in section C. C is the lawn section. It's not the most. But if I wrote this expression, A plus B plus C, what would they add up to?
2,300.
23,000.
1,000.
Does that make sense to you? All the numbers of seats in each section, which I don't know how many is in each section, but if I add them up, I know it'll be 23,000. And notice, remember what the question asked. How many are in each section? Well, there's A in A section, and B in B section, and C in C section. And we will have, when we figure out what A, B, and C are, just like we just found out how to find out what X, Y, and Z are, when we find them, then we can answer that question. So these are our variables. This is called the number equation. It has to do with how many. Now we're going to write the value equation, what they're worth. Do you understand that if I took 75 times the number of A seats, this would tell me the revenue from A section. The number of seats times $75 a seat, this expression tells me how much money I'm going to bring in from selling seats in the A section. Does that make sense? What's going to be the B?
5.
55. 55 times the number in B, because that's what B is the number of seats there, plus 30. 30 C equals, now we're talking money. What's the total take for the sales?
870,000.
870,000. Okay. That's only 2 equations, a number equation and a value equation. That's all we've got, and that's not enough. If you have 3 variables, you have to have 3 equations. That's where that middle sentence comes in that you have to be really careful with and translate it very carefully. That middle one said, there are 3 times as many seats in B as in A. How can I relate those two? 3 times as many seats in B as in A. How can I write that equation? 3 times 3 times A equals B. That says if I took the number of sections or the number of seats in A and multiplied by 3, that would be the number of seats in B. Now, why did I write that over here instead of down there? Because I've got to take this expression, which is a direct translation of those words, and I've got to write it in this form so that all the A's and the B's and the C's and the equal signs and constants line up. So to manipulate this, that would be 3B or 3A, because that's supposed to lead out. A is supposed to be first. Bring the B over. There are no C's in this equation. Equals 0 because I subtracted the B over to this side. You see how I manipulated that expression, which was a direct translation, into an equation that will fit with these?
That's all you have to do.
Well, yeah, you got to manipulate this so that it looks like this. And if there's a variable missing, you put a 0 for its coefficient. So now I have this for my third equation. 3A minus B plus 0C equals big fat goose egg. But we have to directly translate this, and then we have to change it algebraically to a form that matches this. Now I have my 3 equations. Do you see it? On the test, I ask you in a story problem to come up with these 3 equations. But then I say, solve it however you want, and I would recommend a calculator, especially with a number this size. I don't want to deal with that with my systems of equations. So I'm going to kill 2 birds with 1 stone. You got to take the words and sometimes a diagram or whatever, and you've got to come up with these 3 things. Number of seats, value of seats, and some other relationship that you manipulate. When you get this system done, you can make your calculator find the answer, and that's really cool. I'm going to show you how right now, and then you can review this video if you like. Now, I realize that you guys can't see this equation over here, but you can if you watch the video. Maybe you can see part of it. This is what you do. Are you ready?
Where's the video going to be on YouTube?
What?
The video's going to be on YouTube?
Yes. It's going to be on my channel, if you can find it. You may have to get some help from somebody to find it. Okay? So we want to be able to put this system into this calculator and make it do all that horrible grunt work that I just showed you how to do by hand. And it goes really fast. It's really cool. But you got to know what buttons to push. Okay. What we want to use, what we have to access first is an app. Can you see the little purple key that's third down in the second column?
Yep.
It says apps. Okay, now your apps may not look quite like mine. I may have more than you do. Or maybe yours looks a lot like mine. Okay? Does anybody go into the apps and they have a very, very short list? Anybody got a super short list in theirs? I'm going to have to maybe load yours up. Okay? But let me go through this process. You can watch the video once you have it on there and you can. Okay. All right, so what you have to do now is you have to go to the P section because I'm going to use a polynomial simulator is what we're going to do. And so you have to go alpha. See the green key? That refers to the letters. You're going to have to go alpha and 8. See the P above the number 8? And it will immediately take you to the P portion of this list because it's a very, very long list. And just holding your down arrow will get you there. It takes a long time.
You have to go to apps every time you do this, like
This application, yes. Do you want me to start over? Anybody need me to start over? Okay. In the P section of this, mine says polysmult. Yours might say polysmult 2. It's the same thing. Stands for polynomial simulator. There's 2 different versions of it. I have the first version. Go to that. Hit enter. Texas Instruments will take credit for writing the program, so just hit enter again. And then you should have a list here of things that this particular app can do. Do you have this list? We want to use the simultaneous equation solver. That's what these are simultaneous equations. So you go down to number 2, choose enter. And the first thing it wants to know is, how many equations do you have? Number of equations. And you type,
Mine does not look like that.
okay, fine, just hold your shorts on a minute. Does anybody's look like this? All right, for you peoples that look like this, follow me. The rest of you just sit tight, don't panic.
Too late.
Choose 3 because we have 3 equations. Unknowns means variables. We have 3 variables. So choose 3. Hit enter, and you will get something like this. Those of you who have a different version will also get something like this. So pay attention to this screen. I'll show you how to get there in a minute. This will give you 3 things. This right here stands for your equal sign. What?
How do you clear the document?
You don't have to. Every time you type over it, it will take the new one. Okay? You don't have to. I'm not sure how mine got cleared unless I reset the whole thing at some point. Okay? Notice it says 3 by 4, but that's because there's a 4th element where your equal sign goes. So this is the equal sign. And the numbers that you put in here are not the A, B, and C, just the numbers in front of them. So I know you can't see this very well, but the first equation was A plus B plus C equals 23,000. We're going to put in 1, 1, 1, and 23,000. Why ones? Because those are the coefficients on A, B, and C. And notice that as you type 1, enter, it moves along and it comes right down to the next line like you read a book. Now we're going to do the value equation because that's next. And it's 75, 55, 30, and 870,000. And that may not show up here. It didn't show up here fully either because it won't fit in the screen. But when you see that little dash right there, it means there's more to follow if you want to find out. All you have to do is put the cursor on it and we'll show you down here how big that number is. Y'all with me? And the last one is 3, -1, 0, and 0. Do you understand how to get the system that you wrote and get those numbers off of there into here? Now all you have to do, now this is kind of interesting. You'll notice on your calculator, these things right here with a big line over it, they're separated like this. In the programming of this calculator, of this particular app, these buttons right here, up here, have become these things. What do we want to do? We want to solve, and that's the very last one. We want to choose this by using the key just below it. Hit solve. It'll take it a minute. There's a little worm that works up here while it's working on it. And here's what we have. Notice this isn't A, B, and C because calculators know that's the variables we use. This is A. This is the first one in the upper left-hand corner of our system. This is B. This is C. There are 1,500 seats in section A, 4,500 seats in section B, and 17,000 seats on the lawn. A lot quicker than solving this thing by hand.
Yeah.
Now, who does not have that? Okay.
I know, but I figured it out.
Good, that's excellent, because it wants the same information, it's just given slightly differently.
Right.
So if you have this instead, all you gotta do is move over to the 3. Choose 3 there and hit enter. Come down here, unknowns 3, so move it over, whoops, come down here, move it over to 3, enter. You want your answers as decimals if it's talking about money. So go to here and highlight that for decimal. The rest of it, leave it alone. Then, again, these little boxes right here indicate that these keys have become those things. So I want to choose next, which is the graph key. Then you want to put your numbers in there, just like I just taught you. So it would be 1, 1, 1, 23,000. You see what I'm doing with your calculator? Yeah? Okay, 75, 55, 30, and 870,000. And then 3, and -1, and 0, and 0. And again, we're right where we were before, and we hit solve by hitting the graph key, because that's what that key does. Wait, oh, yours took really fast. Yours went really fast. And you got to understand that this is your A value, B value, and C value, and in the scenario of this problem presented, these are numbers of seats. If it were X, Y, and Z, then this would be X, this would be Y, this would be Z. You following?
Yep.
Okay, now, with that done, I want you to do I've got about 10 minutes left. I want you to do one with me that has no solution so you can see what your calculator gives you. Okay? So let's go back and have the calculator solve the system that had no solution in example 2. So go back to example 2, page 32. And here's how you get back, after you've solved something, here's how you get back. You either go back or you go to main. I think I will choose back. I'm back to, and ready to edit a 3x3. And I want to do the equation that I did, or the equations, the system I did in example 2. Are you looking at example 2? Get your eyeballs on example 2. And when you're here, even though this stuff pertained to our concert situation, as you type over this, it replaces it with those numbers. There's no saving that you have to do. Okay? So we're going to enter the numbers 1, 1, 1, 2. Replace those. Now I'm on the second line. Make sure you include negatives as you go along. It's going to be 5, 5, 5, and 3. And the last one is 4, 1, negative 3, negative 6. You may want to adopt this little checking mechanism. I'm a very auditory learner, which means that what I say in my head is what I remember. So if I check this and I say, oh yeah, I said 1, 1, 1, 2. If I said that in my head and typed it, I'm going to convince myself that's correct. So when I go to check my numbers, I always check them vertically because I haven't seen that sequence of numbers yet. I haven't heard them in my head. So I'm going to look on here and I'm going to go vertically. The X's are 1, 5, 4. Good. The Z's or the Y's are 1, 5, 1. 1, 5, 1. Good. And the Z's are 1, 5, negative 3. 1, 5, yep, negative 3. Good. And my constants are 2, 3, negative 6. 2, 3, negative 6. You might want to check vertically so that you don't convince yourself of something you've heard that may be an error. Do you know what I'm saying? Okay. When you're sure of that, and by the way, when people type this number right here, if you fail to hit enter, it will not remember it. So if I'm back over here and I say, okay, the numbers are 4, 1, negative 3, negative 6, and I go like this, 4, 1, negative 3, negative 6, and I don't hit enter, it will remember what was previously here. Make sure you hit enter after every single one. Okay? That's a big error right there, is they forget to hit enter on the last one. Okay, so now we're going to solve. Hit solve, because we want to find the solution.
No solution found.
Yep.
Oh.
Now, what would happen if there was an infinite number of solutions? Let's look and see. Because you need to be able to see what your calculator does for that too. Okay. So go back and let's do example 3. Everybody put it in yourself. I'm not going to talk you through it. Just put it in, all those numbers. See if we can figure it out. You might want to check because there's a lot of negatives in this one. Make sure you hit enter after the last one. 1, 1, 5, negative 1, negative 1, negative 5, 1, negative 1, 1, negative 3, negative 3, negative 15. Okay, I'm going to hit solve. Well, that's weird. It didn't say no solution because it's not no solution. It's an infinite number of solutions. When you guys hit this when you hit this problem on your exercises, I would recommend you go through and do it by hand because Big Ideas Math will not accept this particular version of the solution. However, on the actual test that I give you that's written, I will accept this version so your calculator can do it for you. I will accept this version. The answer to this question is not only infinite solutions. It's saying that every solution to this equation, every solution to this system will take on this form. This is what you write. The x1, meaning the first element in the point that we're going to write, is y minus 3. Where did I get y from? That's what x2 is. x2 is y. And I don't like negative 3 plus y. I prefer my variables to be in the front. So I put the y in front and then the minus 3. And that's what x1 is. That's what sits in the first position is y, which y minus 3. What goes in the second position? Y. x2 is x2. That's the one that we're going to write everything in terms of. And the last one in this case turns out to just be 0. Z is always 0. But all the other points on the solution, millions and millions of points, will take on the form, whatever this is, this will be 3 less than that. So what I'm saying is that one of the millions of points on this thing is 6, 9, 0. Because these will always differ by 3, this one 3 less. If I have negative 3 here, then this will be 0, 0. If I have negative 12 here, then this will be negative 9, 0. So these are all points.
Is there any way of just like quickly looking at it and knowing that it's like?
Yes, there is. If you'll look with me in example 3, you'll notice that it's not a really quick way. Let's see. You'll notice that if you multiply the first equation, the entire thing, including its answer, if you multiply the first equation through by 5, you get the third equation. If that ever happens, where one is an exact multiple of the other, all the way through, clear to the other side, there will be infinite solutions. Because one line is exactly, before when there was no solution, it was because one line was parallel to another. The planes were parallel. In this case, there are 2 planes that are exactly the same. The other one hits like this, and they hit in a line which is related this way. Weird. Okay, so there is a way to tell. If one is a multiple of the other all the way through, then there'll be infinite solutions.
Are they like an exact relation?
Yeah. Like what?
Like 1 minus 2.
Yeah, and the calculator will tell you how they're related here. When you go to do it, if there's an infinite number of solutions, it will tell you how they're related. Just don't forget that this is x, y, and z. So when you see the subscripts, you got to interpret that as x, y, and z. Think you can handle this? It doesn't matter if you don't think you can, you have to. So here's the assignment. I'm going to keep this going so that whoever's doing this on paper can write this down. You ready? If you're going to do this assignment on paper, here comes the assignment. If you can do it on big ideas, you'll still be doing a lot on paper, I would think. Here we go. 3, 5, 11, 14, 17, 18, 24, 25, 33. That's 1, 2, 3, 4, 5, 6, 7, 8, 9 problems. But as you can imagine, each one's going to take you a little bit.
Yeah.
Especially the first ones, because you haven't done it yet. One thing, for everyone, if you're interested, number 39 is an extra credit. So if you can do number 39 and get it correct on your separate sheet of paper and turn it in before test time, if it's correct, I will give you the credit. And add those points, those couple of little points to your test next time to your test score. Okay? Good luck. That's the end of this one. See ya.